I believe everybody has got their worksheets ready. Yeah, okay. So I'm gonna open mine, all right. So let's practice some of the stuff in the worksheet yesterday. Question bank. I'm gonna send you another one, strictly the IB papers on the topic. So it's a different worksheet entirely. That's where your graded tasks will be from, okay? You can turn in later, say Friday or weekend. So it's not something you have to do like urgently. So you can manage your time considering every other thing you might need to do, okay? All right, let's see, I'm trying to minimize this window. One of the things also that we need to talk about today is the graphical solution. So we'll be quick and I'll leave you to do practice on your own, okay? So go with me to the updated version of the worksheet that was sent to you and posted on. Have I sent the updated version to you? The last version. Yeah, I think you sent it. Okay. All right. So let's start with 3x3 begins from section C, which section D, I guess, which is from question 29. Okay. So I'm interested especially in question 29. Does anybody know what to do with that? Question 29 is talking about substitution and elimination method. I want you to make an attempt on that later and show me, and we can look at it together if somebody couldn't do it. So questions 30 to say 35, they are all similar. So maybe we pick one of these and try to do it together. Okay, 30 to 35. So can somebody suggest which to do together? $34. Okay. Okay, so I'm going to show you my 34. Just a sec. Let me close some of this up that could be a problem. Am I loud enough? I'm trying not to speak too loud. Can you hear me? Okay. All right, thanks. Okay, so how do I share my screen? Let's go. Okay, whiteboard. Okay. Okay. So can you see the worksheet now? All right. Thank you. So Between us suggested we do question 34. So let's look at it together. According to question 34, we have this system. We have that system. Consider that use row operation to reduce to echelon form. Now, everybody knows what echelon form is. Show that for one value of k, the system has no solution. Sorry. Show that for all other values of k, there is a unique solution, and write the solution. Hence, find the unique solution for k equals 3. All right, let's begin. Get your pen ready. This is mine. If you have a pen, I'm sure you do have a pen. So back to the board. Question. Okay, right, so there's dates. Today again, it's difficult to know the dates formally. It's Tuesday 11th. So so that question says, let me see, I should actually put it on. Is the question on WeChat? Did I send it to you guys on WeChat? Yes, I did. Got it. All right, so I'm just gonna hang this here. Okay. Question 34. Just a sec, please. Okay, here we go. So we have considered the system x minus 3y plus 2z equals negative 7. 2x plus y minus z equals 5. 5x minus 8y plus kz equals 12, where k belongs to R. Okay. To put in echelon form, the first thing is what? What's the first thing? Put it in mic, preferably. So you want to solve a problem like this. What's the first thing you need to do from this point?
We need to make it to augmented matrix.
Who's speaking?
Me.
Nakita?
Yeah.
Fine. Sorry, I wouldn't know who is speaking. Thank you.
Okay.
I think I can do something to know who is speaking. Can you still see me?
Yeah.
Okay, now I can see who is speaking because it brings out name. I've done something about that. All right. So thank you. So we put it in the augmented matrix form, and we're gonna have this. So in augmented matrix form, I'm just gonna put that here. This will be 1, 2, 5. This will be negative 3, 1, negative 8. This is 2, negative 1. This is k. And this is negative 7, 5, 12. Okay. Is that the middle? It's more or less the middle. Yeah, whatever. Now, the next thing is to use, okay, actually that's the first thing, row operation to reduce to echelon form. I said something yesterday. Your goal when you have a problem like this, your goal is to do what? When you have it in augmented matrix, your goal, your main goal is to what?
To solve it as it has a unique solution.
Thank you, Brandy. You make sure you work towards unique solution. Now, look at row 1. Is row 1 okay the way it is?
Yeah.
Yes.
Yes. And the reason is?
The coefficient of x is 1.
Perfect. Coefficient of x is 1. Thank you for that. So we need to now focus on row 2 and row 3. So we're going to have to make that 2 0. Okay, we even have 1 already. So hopefully 1 stays there, but it's not guaranteed. This one. Okay, this one. But it's not guaranteed, but so we need to make this 0. So now, adjusting that, we have 1, -3, and 2. We have -7. So what do we do to row 2? Yes, row 2.
Row 2 minus 2 row 1 equals the new row 2.
Right. Row 2 minus 2 row 1 is now the new row 2. Perfect. So row 2 is 2 minus 2 times this gives 0. Row 2 is this minus 2 times this is 7. Row 2 is this minus 2 times this is -5. Row 2 is this minus 2 times this is 19. Am I right? Yes? Okay. Krista said coefficient of x is 0. Yeah. Okay, 100. I don't understand the 100, guys. Krista, Lillian, I don't understand what you type in. Oh, okay. That was a long time ago. All right. Okay, so row 3 now. We're going to do similar thing, right? So can someone tell me what to do to row 3? What row operation do we perform on row 3? Waiting. What row operation do we perform on row 3?
Row 3 minus 5, row 1.
Thank you, Calista. She said row 3 minus 5, row 1 is now the new row 3. Let's see. Row 3 is 5 minus 5 times this less than 0. Row 3 here is -8 minus 5 row 1. That's -8 plus 15, and that gives 7. Oopsie. Row 3 is k minus 5 row 1 will be k minus 10. Properly. K minus 10. See that clearly? Then row 3, 12 minus 5 times -7. 12 plus 35. That is 47. Just let me know if something. Is everything okay so far? Please check and let me know if everything okay so far. Good. Okay. So we move on. So now this 7, this needs to be 1. And this needs to be 0. So we move on. So we have 1, -3, 2. Some space here because now this is becoming a term. Okay, so what happens to row 2 this time? Row 2.
Can it be 1/7 times root 2 will be a new row 2?
I agree with you. 1/7 times row 2 is the new row 2. Okay, I hope everybody gets that. And please contribute. The more contribution you give, the better understanding you have. Okay, everyone? So this will be 0, this is 1, and this is -5/7. And this will be -19. Is it negative? No, negative this time. 19/7. Okay, then row 3. So what happens to our row 3? We need this 7 to be 0. What do we do? Okay, Clarissa says row 3 minus row 2 is now the new row 3. Thank you, Clarissa. What's happening to your mic, Clarissa? Okay. So this will be 0 because 0 times minus 0 is 0. Okay, I can go and fix it. Yes, that's fine. 7 minus 7 is 0. Then this minus this is k minus what? It's k what? What's the last term? K minus 5. Does everybody get how it is k minus 5? Remember, we have k minus 10 minus 5. Row 3, which is this. Row 2, which is this. The minus between is this and that. So it's going to be k minus 10 plus 5, which is k minus 5. So you have to be careful. The last 47 minus 19, what is that? Anyway, that should be 26. Am I right? Is it 26? Please confirm. 8. So minus 19. Oh, sorry. Yeah. That's what Calista was saying. So 28. Okay. So, but then it doesn't look like echelon form, right? Because we need one here. We need one here. Do we all agree with that? So what can I do to add one there?
K equals 6.
What do you say? Say that again, sir.
K equals 6.
So what can I do to make this echelon form? It's not in the echelon form. I'm not asking for the value of k.
Row 3 times 1 over k minus 5.
Yes, that's what we need to do. Does that make sense, Mr. Cheng?
Yeah.
So this remains 19/7. This will be something we have to figure out. This is 1. This is minus 5/7. Allow me to just stick to the color so we can follow through with the steps from the beginning. So this remains 0. This remains 0. This remains 1. This remains minus 5/7. This remains 19/7. Then for the third row now, we're going to have 0 here, 0 here. Then this is 1, and this is 28 divided by k minus 5. And what has happened is row 3. What has happened is 1 over k minus 5, row 3, is now the new row 3. Everybody get this? Yes? All right. So now we're done with the echelon form. So let's go back to our question. Question says, so this is A, right? We're just done with A part. B, showed that for one value of k, the system has no solution. Okay. So show that for one value of k, the system has no solution. How do we do that? Anyone? For one value of k, the system has no solution. How do we achieve that? Talk to me, please.
If the fraction is undefined, then there's no solution, right?
Good, yes. So what you're saying is there exists no solution. So you say there exists no solution when 28, right? Right? 28 divided by k minus 5 does not exist. Just like we did before. Let me take this away. 28 minus 5 does not exist. And that implies that when k minus 5 is equal to 0, which implies that k is equal to 5. So that is that value for which there is no solution. Okay? Then it says when k is equal to 5, there is no solution. Now, C, show that for other values of k, there exists a unique solution, and write the solution in terms of k. How do we do that? Anyone? When it says all other values, what does that statement for all other values of k? What does that mean? Can somebody tell me what that means first? All except for 5. Yes, every other number except for 5. Okay, so we want to show that for all other values there is a unique solution. So if k is not 5, definitely x will exist, right? Y will exist from this echelon form. Okay, from here. Can everybody see this? So if k is not 5, then z is equal to this automatically. So that's what we're going to do now. So it says show that this, for all other values, there is a unique solution. Write this solution in terms of k. So what we're going to do is from the echelon form, that's from here, okay? So when I'll just start by saying when k is not equal to 5, you see this is very important, okay? We are trying to say when the solution exists. So this statement is very important. When k is not equal to 5, my z will be, sorry, I couldn't place my hand properly. Z will be, what's wrong with me? Z will be 28 divided by k minus 5. That's z. Now, also, okay, also y plus, no, not y plus now, y minus 5 over 7z equals 19 over 7. That's from row 2, and that implies y equals 19 over 7 plus 5 over 7z. Okay, and that implies that y is equal to 19 over 7 plus 5 over 7 times 28 over k minus 5. Okay, and you can divide this too. So you get a 4 here. So that's 19 over 7 plus, that will be 20 divided by k minus 5. And that we can express as a single fraction. Expressing that as a single fraction. So that's 7k minus 5. So 19 k minus 5. Then 7 times 20 will be 140. Please confirm. Am I right so far? I'm waiting for your replies. Okay. Krista said yes. So y will be, if you open the bracket, you get 19k minus 95 plus 140 divided by 7k minus 5. So minus 95 plus 140, what's that? Is that 45? Okay, so y will be, so this implies that y equals 19k plus 45 divided by 7k minus 5. So that's y, this is z. So we go to the first row of the last echelon form. Okay, let me use a different color for that. So also, x from row 1, x minus 3y plus 2z equals negative 7. And this implies x equals negative 7 plus 3y minus 2z. So we substitute again. X equals negative 7, 3 times 19k plus 45 divided by 7k minus 5 minus 2 bracket 28 divided by k minus 5. So this is what we simplify, and that gives us our x in terms of k. Okay, so we do that. So this will be negative 7. Actually, the LCM will end up becoming 7 and this. So I can as well just say negative 7. So I have 7k minus 5 divided by 7k minus 5. Okay. So 3 times 19, 57. So we get 57k plus 105 or 135 divided by 7k minus 5. Here, that would be 56, but we need a 7. So that's 2 times 7 times 28. 7k minus 5. Does this make sense, everyone? So this becomes, so now a single fraction. So this is 49, negative 49k plus, what is 49 times 5? Is that 245? Please confirm. So plus 57k plus 135 minus, can somebody check 14 times 28 for us? Let's add all the k's. So what is this plus that? Is that 8? 8k? Okay, so we have 8k. What about the constant? Add this plus this minus this. And please check twice. So this plus this minus this. What do we have? -12. Okay, somebody confirm that. So in summary, okay, in summary, so I'm going to write the summary of this. Therefore, x equals 8k minus 12 divided by, that's 12 divided by 7 brackets k minus, somebody says something, I'm going to check the chat now. Minimize the chat. Can we go back real quick? Okay, Mr. Chang. Is there an error? Is there an error? Or you just want to copy what I'm doing? Take pics? No, don't waste time taking pics. I'm not done yet, so we can't waste time with this. Come on. This will always be saved and you can always just leave some spaces. Come on, don't take us back because of pictures. So minus, is that 5 in the bracket? I expect you to please follow the solution, not just trying to take picture or copy stuff. That's 5. So y is 19 plus 45. Yes, if the same denominator, 7 into k minus 5. And z, which was the first, okay, z is 28 divided by k minus 5. 28 divided by k minus 5. Crystal C, the third question is up to you. Crystal C, the third question says, hence find the unique solution for k equals 3. What do we do? Please speak to the mic. Can Crystal hear me?
Yes.
The third question. No, sorry, C2. This is C2. I think this is C1. All right, this is C1. C1. Now C2 is this. C2 says find the unique solution for k equals 3. How do we go about that? Can you hear me?
Z equal to 28 over 2.
How do we go about that? You're telling me numbers. You haven't taught me anything. So assuming I have no clue, you haven't done any justice.
Z equal to.
Do you understand the question I'm asking? The last question says, hence find the unique solution for k equals 3. I have no clue. I don't know what to do. So you tell me what to do. Don't tell me the answer. You tell me what to do.
If there's unique solution,
remember, C2 is definitely continuation of C1. That's one thing you need to know. So I don't think you need to think too far. Callista, what do you think? Callista?
I don't know.
In C1, it says show that for all other values, there is a unique solution. That's what we have just done. That's what we have just done. Krista, I'm still talking to Callista. Next time, do not just say the answer publicly. You can actually message me privately on the chat room rather than just say the answer publicly. I don't appreciate that, please. That's why I'm calling specific names, because I have a feeling that they do not understand what I'm doing, and I want to give them the chance to learn. Thank you. So I go over a substitute is the right thing. So C1 says show that there is a unique solution. That's what you have just done. This is the unique solution, because if you look at C1, it says show that for all other values of K, there is a unique solution, and write this solution. What does that this solution mean? This unique solution. So this is the unique solution in terms of K, okay? So, but it's in terms of K. For anything, for any value of K, there will always be different solution, because K is, it varies with different values. So all you have to do, now it says find a unique solution for K equals 3. All you have to do is just put K is equal to 3, okay? So when K is equal to 3, X will be 8 times 3 minus 12 divided by 7, 3 minus 2. That's all you have to do. Then you work it out. Y will be 19 times 3, 19 times 3 here, so it's plus 45. Someone should please check this in the calculator and be ready to tell us, or you can type in what is X, what is Y, and what is Z. Z will be 28 divided by 3 minus 5, which should be easy. 28 over minus 2, which is negative 14. So this will be what? 24 minus 12, which is 12. 7 times 1, which is 7. This is 19 times 2 plus 45. What's that? Or did I put K here again? That should be 3. Oh, this is wrong. That should be K minus 5. So it should be 3 minus 5. Please, I need you to follow what I'm doing. So that should be divided by 14 now. Please confirm. So this is 24 minus 12 divided by that. So this will be divided by 14. So which should be 6 over 7. Okay, yeah, I just figured that out by yourself. So what about Y? This is another 14, but what is the numerator? 19 times 3 will be 57. 57 plus that, is that 102? Yeah, okay. So if you divide by 2, you get 51 divided by 7. Can it still be divided? Can you check calculator quickly? Or is that the last whatever? Don't use decimal, please. That's it? Okay. So that's it. This is your unique solution. When K is equal to 3, you get your X, you get your Y, you get your Z. Any questions?
Daniel, there's a negative, right?
Where?
All of them. 3 minus 5 is.
Oh, thank you. So there's a negative. Thank you so much. Yes, so they're all negatives. Yes, yes. Thank you. Thank you, Krista. Thank you, Clarissa. Thank you, Lillian. So that's it about that one. Any questions? Okay. Can I ask you to try, this is 34, right? Let's say something similar that you could do. How about 33? Is that okay, everyone? So we'll attempt 33. Okay, so do you need me to go back to the previous slide, anyone? Or I just leave this here? Do I need to go back to previous slide? Anyone? Please let me know in the chat, or you just speak to the mic. Yes, yes, go back, or just leave this. Previous slide, please. Don't give me yes, no, please. Just tell me yes, what, no, what. All right, so that's where it all began. So attempt question 33. If you need me to move to the next slide, please say something. Sometimes I minimize the chat, so I wouldn't know if you type in anything. So please just say something. So let's take the next 10 minutes max to look at question 33. Preferably if you spend lesser than that, that would be great. Just practice and keep your answers. No submission required online. Finish your work, you can have one of this. Who wants? Raise your hand if you want. Someone is saying something in the chat. Who's raising their hand? Calista. And who? Clarissa. Oh. Lillian, how about you? Ferry. It's with crystals. All right, let's be fast with that. are we doing? We're done by now. Talk to me, guys. You still working or just waiting for me to ask? Still working. Okay. Working. Still on A. Okay. All right. Who's ready? One, please say something. Don't have all day, guys. Okay. Still working. Okay, I finished A, but not sure how to go about B. Let's see. Show that for one value of A, the system has infinitely many solutions. Find the solution in this case. Okay. When do we have infinitely many solutions? You have to be able to have your echelon form like the one we did, right? So try to, what does your echelon look like for A? Can somebody tell me? Let's put that on the board. Just a sec. Can you still see the board? Anyone? Can you still see the board? So tell me what your echelon form looks like for A part of that question. Please.
The first row is 1, 1, 3, 3, and then the line, and then A minus 1. And then the second row is 0, 1, 5 over 7. And then 2A minus 9, the whole thing over 7. And then 0, 0, 1, 1.
Has everybody got this? Those that have done it? Okay. Can I get my responses? Just 2 people? Okay. Okay, so let's see. A lot of people are double checking. All right. So now show that there is infinitely many solution. If there is infinitely many solution, what does that tell you? It means you have now from yesterday, what are the possible what's it called? Echelon forms you can have. You can either have, there are three forms we talked about yesterday. One, box. What is Z?
I mean that in row 3 should be 0.
Z in row 3 should be 0, yeah?
And for row 3, the last one also should be 0.
So like 0, 0?
Yeah.
Lillian, can you confirm that? Lillian? Anyone else confirm Krista's? Or we just try to reduce it together?
Maybe I calculate wrong because that makes more sense too.
Okay, that would make more sense.
Yeah.
All right. So this is what we're going to do. Let's put the original problem in echelon form together and see where the problem comes. Okay. So the original question, x plus 3y plus 3z equals a minus 1, 2x minus y plus z equals 7, 3x minus 5y plus az equals 16. So in augmented matrix form, 1, 3, 2, negative 1, 1, and 3, negative 5, a minus 1, negative 7, 16. So what can we do to this? First row remains. The second row, I want to make this 0. So it has to be row 2 minus 2 row 1 in row 2. Similarly, row 3 minus 3 row 1 is my new row 3. All right, talk to me please. So this will be 2 minus 2 as 0. This is, can somebody confirm yes or no, please, with these operations? Thank you. I need response in real time. And don't wait for someone to say it. You say it. Everybody might be thinking, oh, someone is going to say yes, please. Row 2 here minus twice of this, negative 7. Yes. 1 minus twice of that, negative 5. Then negative 7 minus twice of a minus 1, negative 7 minus 2a plus 2. So that's negative 5 minus 2a. So somebody confirm that. Minus 2 minus 5. Okay, and last but not the least, this will be 0, minus 3, no, negative 5 minus 3 times.
Hey, Mr. Daniel, it's 7, not negative 7.
In the middle.
Yeah,
Okay, so
like the answer for the middle row.
okay, so for this second row, right?
Yeah. Like you wrote it wrong in the augmented matrix
One.
too.
No, in the top, in the red.
This one?
Yeah.
Yeah.
It should be positive 7.
Oh, positive 7. Okay. Thank you for that. Let's just take the negative off. So this is 7. So if that is 7, it's going to affect something here. So that would be 7. So this will be 7, 7, 9. Am I right? Would it be 9?
Yes.
Okay, so 9 minus 2a or negative 2a plus 9. So I'm just going to leave it at negative 2a plus 9. Okay now? Okay, so the middle one, minus 5 minus 3 times 3. Is this negative 14? Let's confirm. Okay, then a minus 3 times 3 is a minus 9. And 16 minus 3 times a minus 1. 16 minus 3a plus 3. 19 minus 3a. Okay. So that's 7, negative 7, 1. Multiply by 1 over 7. So this remains 1, 3, 3. That remains a minus 1. So this is 0, 1. So what we're going to do here is minus 1 over 7 R2 is the new R2. Okay, so that will be 5 over 7. And this will be, I'll write this as 9 minus 2a to avoid confusion, divided by, oh, there's a negative. Okay, Abba will just put it as a bracket. Negative 1 over 7 bracket minus 2a plus 9. Let's confirm that. And for this, to make this 0, can use that. So we need minus 14 minus 2 times minus 7. So that's root 3 minus 2 root 2. So root 3 minus 2 root 2 is the new root 3. Can I get a yes or no? It is 0, 0. The middle one is 0 because it's minus 14 minus 7. So minus 14 plus 14 is 0. And the last one, a minus 7, that's root 3 minus 2 root 2, which is negative 5. So a minus 7 plus 10, that is a plus 3. Yes. And then the other part, 19 minus 3a minus 2 row weight.
The third coefficient is a minus 9.
Where does that come from?
Like row 3 is a minus 9, but you roll a minus 7.
Oh, too much. This is why I need you to say something. Thanks to those that are saying something. So let's take it again. Row 3, that's a minus 9 minus 3 times 3. No, 2 times row 2. A minus 9 minus 2 times minus 5. Am I right? That'll be a plus 1. Is it? Talk to me, please. Hello? Oh, okay. Did you just type in this yes? Because I wasn't looking at that comment section. So a plus 1. So let's do the same here. 19 minus 3a minus 2 times negative 2 plus 9. 19 minus 3a plus 4a minus 18. So this is positive a. This is positive 1. So a plus 1. I guess it's going to be 1, 1, not 0, 0. So Lillian is right. It's going to be 1, 1. How do you get 0, 0? For those that did it. So let's, just to avoid, just to, correct the impression that you might have. Can you walk us through how you got 1, 1? So this is going to be 0, 0, 1. This will be 1. This is a minus 1. This is negative 1 over 7. Negative 2a plus 9. So what we have done here is 1 over a plus 1 R3 is now R3. Yes, does it make sense? Okay. So now the question is, show that for one value of a there is infinitely many solutions. When can we get infinitely many solutions? When a is plus 1, what happens? Yeah, that's when we have infinitely many solutions, when a is plus 1, which is from here. When a is plus 1. Okay, it's actually from there. Can you get that? When a is plus 1 from here, this will be 0, this will be 0. So you wouldn't have this echelon form. That's the point.
Wait, isn't it supposed to be when a is negative 1?
Negative 1, sorry. That's what I meant. When a is negative 1, so you're going to have 0, 0. Then you have your infinitely many solution. Does that make sense? So I'm not using the last echelon form now. I'm using the second to the last to answer that question. Okay, so what I could do if I was solving it, if I call this maybe star, so I could come here to say come here to say from asterisk, there is infinitely many solution if or when from asterisk there exists infinitely solutions when a plus 1 equals 0, which means when a is negative 1. So when a is negative 1, you're going to have 0, 0. And that is one of the echelon forms for infinitely many solutions. Does this make sense, please? Okay, so then it says find the solutions in this case. Now you can proceed. So once that is the case, it means your echelon form is this B. Yes, this is B. So your echelon form now becomes, this will be 0, 0, your echelon form, right? Then this will be a number. In this case, we have, so I'm going to write the echelon form. So that's 1, 3, 3, 0, 1, 5 over 7. So when a is negative 1, this will be negative 2. When a is negative 1, what is that? That's 2 plus 9, 11. So negative 11 over 7. Please confirm that. Am I right so far? Please talk to me. And the third row will be 0, 0, 0, 0. So this is your echelon form. So from this echelon form, find your general solution in terms of parameter, of course. And the last question, show that there is a unique solution for other values of A. So then we can go back to this. Okay, so I can call this double star. Call this asterisk, double asterisk. I can Just label it equation 1, equation 2, since there is no 1 and 2 referred to in the question. Okay, maybe I use that because asterisk can be somehow sometimes. So what I'm going to do is I'm going to call this equation 1, equation 2. So here I refer to equation 1, and after you solve this, for the last one, which is C, you now refer to equation 2. That is when A is not equal to -1, which means you have your 1, 1 indeed. Then, of course, the first one will be Z is equal to 1. All right, then others can be in terms of A. Does this make sense, please? All right, so complete it. So everyone, do you understand? Few people reply. Can I get a response from others too? All right, good. So let's complete that quickly. Yeah. So that's the trick. This is why it's good to practice. We can all learn from various tricks you can apply. Let's complete it and send us the, maybe on the WeChat group, your parametric form of the solution.
So Daniel, for the parameters, is it supposed to be like let Z be Q or something like that?
But Z is already 1. Z doesn't need a parameter, does it?
Oh, okay.
Z doesn't need a parameter.
No, I mean for B.
Oh, you're talking about B. Oh, okay.
Yeah.
Okay. For B, you have this, right? You have Y plus this Z equals this. So you use anything for your, for it could be Y, it could be Z for your T, anyone. So I just take Z to be T, being the first variable that we always get. But you can do,
okay.
So maybe just stick to Z is equal to T, then get Y in terms of that, and then get X in terms of that as well.
Okay.
All right. We done? I want to show you something, so please quickly. You say something in the chat if you're still working or if you're done. Working on C, okay. Nebo, ancient co-washer. Well, if come so that you can what? So you can oh, okay. Are you guys there? It's taking forever. Just 10 minutes ago. Can I have everyone's attention? because we do not have time, so you can always do the rest of the practice on your own. These questions that I'm compiling at the moment are from IGCSE. So I want to especially, well, look at number 1, for instance. Can everybody hear me? Okay. So look at question 1, for instance. That's kind of easy. Can you see the question? Can you see the worksheet? Okay, great, great, okay. So question, let me see. So I can see the chart side by side in case anybody says something. All right. So question 1 simply says, consider the following, blah, 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 find the value of A, blah, 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 just like the exercise you have just done, yeah? Now, this is a word problem. Does everybody know how to interpret this? Boxes of mixed fruit are on sale at a local supermarket. Box A contains 2 bananas, 3 of that, 4 of that, and it costs this. So you form 3 by 3 equation and you solve. Now, how to solve this? It doesn't have to be row operation unless otherwise stated in IEB. You can use other method, the elimination, the substitution, the Cramer's rule, and the row operation is just the 4th method. There are 4 ways of solving this 3 by 3. Unless it is stated, you don't, unless a particular method is clearly stated, you can use any method. So, but for any exercise we're doing currently, I want you to only focus on the row operation technique because that's what we are learning, all right? But in the standard exam, you are free to use whatever method that comes to your mind first. One of the work I will ask you to do is to attempt the elimination and substitution so that if you are not able to do it, we will do it together next time. So this is what I want to talk about. The following system of equation represents 3 planes in shape. Basically, your 3 variable equation is a plane. Remember, so come with me to the board. Can everybody see the board? Okay. If you have x equals 2, this is a point on your real line, for example, x is equal to 2, that's a point, okay? This is a point, okay? And of course, it can be the point x equals 2, now let me put it that way. Come on. This represents x is a point x equal to 2, right? At the same time, it is the equation of the line that passes through that point x is equal to 2. Now, if you have it in form in 2 variable, maybe x plus y equals 2. Now, this is the equation of a line. If I write this line, I get y equals minus 2 minus x plus 2. So which means we're going to have a line like this, okay? A line that passes through the y-intercept 2. So it's going to pass through 2, so something like that. So this is the line, okay? Then, if you have x plus y plus z equals 2, this is a plane, not just a line, a plane. That is what I want to show you in the graph, a plane, okay? So when I say plane, talking about maybe something like this. Is a plane, I'm not sure if I did the exact, the sketch correctly, is a plane in the 3-dimensional surface, something like this, okay? This is a plane. Please confirm if you understand what I'm talking about at the moment. Yes? So when you have a 3 by 3 system, you're not talking about a line anymore, you're talking about a plane. because you're referring to the x-axis, the y-axis, and the z-axis of a three-dimensional plane, okay? So when you encounter problems like this, it says the following system represents three planes. So this is one plane, this is one plane, this is one plane, okay? Find the coordinate of the point of intersection of the three planes. Just like when you're solving a 2x2 simultaneous equation, you talk about the coordinates of point of intersection of the two lines. This time around, you'll be talking about the three planes. Here's a similar question. The three planes having Cartesian equation, this is the Cartesian equation of the three planes, meet at point P. Find the coordinate of P. Basically, solve this 3x3 equation. Does that make sense? So when you come across question that has to do with plane, when I send you this worksheet, that's what you should do. Okay? So this is another one. Look at this 11 that I just typed. This equation, the equation of three planes are given by this. Given that A is equal to 0, show that the three planes intersect at a point. What does it mean when it says the three planes, show that the three planes intersect at a point? What does that mean? Anyone, quickly. There is a unique solution. Yes, a unique solution. Yes, that's what it means. There is a unique solution. Okay? I don't understand what you mean by at a point. That's this language of the question. Show that the three planes intersect at a point. Mr. Cheng, you wrote back to me at a point. You have not explained what it means. Okay? It means there is a unique solution. Okay? Find the value of A such that the three planes do not meet at a point. What does that mean? Do not meet at a point. What does that mean? It means there is no solution. So you just go through with whatever you normally do. Now, you are working on paper algebraically, right? We're talking about the geometric interpretation of what you are doing. And that's why I've sent you a link, okay? The link I'm sending you on GeoGebra is the page where you can visualize as you will see. Can everybody see my desktop? Can everybody see my desktop? All right, so I'm trying to open my GeoGebra. So I've tried to plot one of the questions. I don't know where I got this from. It's definitely from the worksheet. Let's see. Okay, so this question, question 3. Okay, can you see this? The following system of equation represent three planes in the space, in a three-dimensional space, all right? Find the coordinate of point of intersection of the three planes. Of course, you are not expected to use graphical approach. I just want you to see it. So when I plot it one by one, so we're going to do it over again, all right? Let's do it again. So I'm not just showing you, okay? So you click on the link that I sent to you, okay? Once you get to this page, now it's opening again because I pretended like I don't know what it is. Come on, leave, all right. Recover, no, don't recover. We don't need it. Okay, so at the beginning, this is what you have. Sorry, I want to minimize this. Okay, so this is what you have. So I'm going to close this. I don't need it. I can type in here. Okay, so I picked the first question, the first plane, equation of the plane, which is this one, x plus 3y. So you come to your plot, x plus 3y, okay, then plus z equals -1, plus z equals -1. So can you see the plane? Can you see that? So that is represented by that plane. So we put the next one, okay? The next one is x plus 2y minus 2z. X plus 2y minus 2z. equals 15. Okay, once you go to tab or you just click on the next input, it automatically plot that for you. Then 2x plus y minus z, I suppose, equals 6. And that is the third one. So to be able to visualize this properly, I'm going to change the colors. I think we can do that in settings here. So I pick red for that. I don't know if green looks nice. Nice. Mr. Nice. I pick green for that. And maybe we just leave this the way it is. Okay. Now, everybody can see my screen. So these are the 3 planes. Okay. So I'm going to turn it around. Of course, you can move it around. So this is where they meet. Let's see where the 3 meet. Where can we see that? The 3 doesn't seem to intersect. That type something wrong. X plus 3y minus, yeah. X plus 2y, 2z, 15. 2x plus y minus, yeah, equals 6. Okay. Find the coordinate of intersection of the 3 planes. I'm supposed to get 1 point where these 3 meet. Oh, the third one is not showing. Can you see? Can you see the mistake I made? I just highlighted it. I never put the... I'm trying to bring out your comments. Please talk to me in real time so I know if you are getting what I'm saying. Okay. So I forgot to, so if you do this, I already removed it. Like I made it white basically, so it doesn't really show us what it is. So you can leave it as that color or you could change it to another color. Okay, you can play around with this GeoGebra thing, whatever you want to do. I can decide to make this that one or maybe this one. It doesn't matter actually, but don't make it white. White means it just blends with the background. How about we just take that one? Okay, let's take that one. So these are the 3 planes. So the red plane is the first equation, the green one is the second, and the third. So now, can you see as I'm moving it around, you can always visualize where they meet. Do they meet at a single point? Yes, they do. Can you see that point? Talk to me, guys. Can you see that point? They kind of meet somewhere. Where can we say they meet? They don't meet here because 2 intersect here, but not the third one. But towards this side, looks like the 3 of them meet there. You can look at it from the top also. Aha, did you see that point of intersection somewhere there? This is where the 3 of them meet. Yes, talk to me, everybody. Okay, so this is where the 3 of them meet. Okay, so this is just a graphical visualization of it. So if you lose that link, just go on Google and say 3D graph plotter. GeoGebra is one of the wonderful apps you can use to visualize such. And it also allows you to rotate it so you can see it clearly when you turn it around. You're welcome to check for other apps. Please share with the class once you see it. So clearly you can see from here. You can zoom out to see. I just messed it up. Thought I was going to enlarge the shape. Anyway, let's take it back. Anyway, does everybody get this? So once you solve a problem, feel free to use the graphical approach to visualize what you have solved. Okay? Feel free to do that. You might not be able to see the coordinates easily, but if there is infinitely many solutions, maybe someone could try to do a question that has infinitely many solutions. Wait, did we do any infinitely many solution problem? Maybe we could plot that and see why it has infinitely many solutions. We could plot that. Did we do any recently with infinitely many solutions? Yeah, the last question, when A is 1, has infinitely many solutions, correct? The last question you solved. Isn't that question 33? Yes, talk to me, please. Is it when a is 1 or when a is not 1? Show that for one value of a, there is infinitely many solutions. Is it when a is 1? Can I get a response? There's 3b, yes. So when a is 1. Okay, so let's put a equals 1 into that equation. So I'm just going to modify this. The equation for 33, so whenever I see a, I put -1. Yeah. X plus 3y plus 3z this time, plus 3z equals -1 will be -2. Agreed? Then the second equation, 2x minus y, then plus z equals 7. Uh-oh. Let's see what the graph looks like with this so-called infinitely many. Okay. 3x minus 5y, then -1 equals 16. Confirm if I'm right. Confirm quickly. Okay, so let's see the graph. How do they meet in many places? We can see one here. Now, this plane doesn't end here. Remember, it extends indefinitely, right? Okay, the red one also will extend indefinitely. So I'm trying to see if we have what it means to have many. It means we're going to have different places where they meet. Can you see one already? Anyone? I think somewhere, yeah, they're kind of interlocking, and I want to see the place where the three of them actually, we can see the three of them actually meet. And we have to have more than one. We can't even count it, basically. I haven't seen. I'm not able to visualize this properly. Anyone? 2x, not x squared. Where did that come from? Oh, okay. Oh, okay. Like that? That shouldn't affect it much though. They are of different. Okay, I can see they all meet here. I think they all meet somewhere here also. Can you guys see it? I see like 2 already. This is one situation. Can only see one here so far. Can only see this, which is this part, right? Can only see one here so far. Are you sure it is when a is -1, they have infinitely many, or when a is not -1? Hello. The problem we solve, okay, when a is -1, yeah, which is what this equation become, right? I can see one here already. We're supposed to have infinitely many, except in the case where even if we enlarge this, are they likely to meet elsewhere? This red will always continue to go indefinitely on both sides. The purple one will go like that. The green one will go like that indefinitely. So how they tend to meet, indefinitely is what I'm trying to figure out. So, but in any case, this is what the plane looks like.
Mr. Daniel, for 33b, where a is -1, there's only 2 equations, right?
Okay.
Maybe that's the thing.
Yeah, okay. Even if we have a system, right? So if A equals minus 1, we should still be able to get the same thing. How do I say? We should still be able to plot the 3 and be able to visualize that.
Oh, okay.
Our echelon form reduced to 2 equations, right?
Yeah.
So putting those 2 equations, okay, if I remove this, for example, can you see?
Yeah.
You still have many, but look at it this way. Your point is actually not, look at it this way, it's not just one point really. If a plane, did you see where they meet there? If a plane meets another plane, okay, I think this is better. That might explain it properly, what you just said, because if you have just 2 of them, can you see there are actually many points? See that? Did you see my cursor?
Yeah.
Hello, did you see my cursor? So that might just be the way to visualize it. I think I quite agree with you. So we'll be having just 2 of them, but those 2
Oh, and also the equations are different because
What?
we changed them around.
I know, I'm just saying, like if you have 2 equations for 3 variables, it is easily seen that there are infinitely many.
Oh.
It's easily seen. But what I'm thinking is, even if we have our 3, we should be able to visualize the infinitely many because that is the original problem. And when A is minus 1, we're supposed to say, oh, this system of how many? System of 3 equations has infinitely many solutions. That's what I'm trying to visualize from the graph. Do you get my point?
Yes.
But as the case is now, we can't really visualize that unless we are dealing with 2 equations. And when you have 2 equations, it is easier to visualize it. Look at this. It is easier to visualize that there are infinitely many. Look at this, for example, they meet here. Sorry. What's going on? This, for example, they meet here. Can you see? The green and the purple, they meet here. So all the points on this surface, okay? There's a line here, right? All the points on this line are the solutions. And for points on the line, there will be 3 coordinates. You have the x, any point here, we have the x coordinates, y and z. This we have x, y, and z. This we have x, y, and z. So my point is we should be able to, one way or the other, visualize it even from the original problem. That's what I'm trying to make. But the easier way will be to deal with the 2. It's just like you dealing with one of the equation and you want to actually visualize. Yes, you can, because if you look at it, considering the base of the plane, okay, considering that, look at this red one alone. Where is the equation? Maybe we can say, oh, where it crosses this gray. Can you see that? Where it crosses the gray? And there are a lot of points on that plane. If you have 2, where you can say, oh, where the 2 of them meet. So if we have 3, and we claim that this system actually gives infinitely many solutions, we should be able to visualize it. That's what I was trying to do. Does this make sense so far, anybody?
Yes.
All right. So this is how you can play around with 3D graphing. You know, familiarize yourself more, share your thoughts with class, whatever you find out, and we'll see next time. Any questions so far? So once I'm done compiling this, I have all the questions here. But I want to typeset it properly. I think I just need few more minutes. You can see some of the concepts used are matrices concepts. We haven't done grammar through, so we won't go into that. I just need to add a few more questions. I'm already on, this is 16, and I think I'm about to put in maybe question 15. Okay, I removed the topics that are not needed yet. So, okay, 13. So once I'm done with that, I will send this to you and I will tell you which topic, which questions to do and when you should submit online. Are we able to print? Class, are you able to print, please? If I send you something to print and maybe work in it. Okay, I'm just seeing the chat now. Yes, yes, yes. Where is my chat? No, okay, not everybody can print, so no problem. So what I'm going to do is you work it out neatly on your piece of paper, the A4 or line paper, either A4 or line paper, neatly. If you need to divide the column, please divide the column. Let your margin be clearly visible. Write your name, as you always do, then scan it to me. Okay, you can take a very neat picture, but please do not take a picture with, oh, your pen is beside this and you have chocolates on that side and I have to zoom in to see what you write. Take a picture with the appropriate orientation, like make sure you are at a right angle of inclination when you're taking the picture of the paper. You get my point, everyone? So you take a picture like that, or you can use maybe Cam Scanner or whatever scanning app that is available on iPhone store online. What do we call it? iOS store or Apple store. So take a good picture and upload as a submission. If you have done it in 2-3 pages, you can upload, the 3 of them together. If you think you have done it in 1 page, please don't write too tiny. Remember, I have to enlarge this to see your handwriting. So this is not a time to write too small. I'm talking to those with tiny handwriting especially. This is not a time to manage the margin and try to squeeze in 3 steps in one tiny space. Please, if I get frustrated, I probably wouldn't spend much time reading your solution and probably just give you an average point. So you need to write clearly, convincing, and not too tiny. If you can use a white paper as your background, I think it might be better for the picture. If you use something, the brown paper, and you write on a pencil with it, it may not be that clear on your ink, on your picture, okay? Just guideline, I'm not trying to restrict your method of submission, but please be mindful of these things as you plan to submit the work I'm going to send to you within the hour. Any questions before we leave? All right. So we're going to meet on Thursday. We'll start functions, which is topic number 2 in the IB syllabus. Finally, we are done with topic 1. I can't believe we have to do that online. Anyway, but it's a good thing we had whiteboard online. All right, Karen can now go back to sleep, and Nakita can go back to her coffee. Kidding. Right, while I go back to all this, Lillian will definitely go back to math. We all know that. Krista K will go back to what? The usual laugh. All right. I'll see you guys on Thursday. Game. Okay, Krista is going back to game. Mr. Nice, what have you been up to? I haven't heard from you. I think you spoke today. Sleep. All right. So where have everybody going back to? Share with me what you're going back to do before we go. Game. Okay. Food. I like this. Food. Coffee. Nakita, I was only kidding about coffee. Are you really going back to coffee? Rabbits. Clarissa, really? All right. Okay, you guys have fun. I'll see you on Thursday. Say bye to the class and you may leave the room. Bye, 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 bye.